This lecture introduces us to the hypothesis testing. So what is a hypothesis test? It is a process that uses sample statistics to test a claim about the value of a population parameter. So the use sample statistics means you have to collect a sample and use a sample statistics to test whether a claim about a population parameter is reasonable or not. A population parameter can be a population mean, or it can be a population standard deviation, and so on and so forth. So in different fields, such as medicine, psychology, or business, researchers heavily rely on hypothesis testing to make decisions about the new medicines, about new treatments, or about new marketing strategies. For an example, in 2010, a nonprofit group from Long Beach conducted a study on a possible link between coffee beans and cancer risk. So they noted from their experiments, they noted that there's a possible link between roasting coffee beans and the likelihood of getting cancers, because roasting coffee beans produces acrylamide, a chemical that has been linked to increase cancer risk when given to rodents, right, in a high concentrations. So in March, Judge Barr ruled that coffee had to come with cancer warnings. And since then, coffee companies has been geared up for years of appeals. So you can read about this the trials in this case on this link. Okay, so the very first step of hypothesis testing is stating a hypothesis test. So in hypothesis test, there are two different statements. First statement is the null hypothesis, and the second statement is the alternative hypothesis. Okay, and this statement is revolving around a population parameter. All right, so in the two statements, one represents the claim and the other one is a claim's complement. So in hypothesis statements, the null hypothesis always contain a statement of equality, such as less than or equals, or greater than or equals. Again, in the null hypothesis, the null hypothesis statement always contains a statement of equality. And the alternative statements, it's just the opposite of the null hypothesis statement. So if you have if your null hypothesis is, you claim that the population mean is less than or equals a value k, so this is the claim, right? Then the alternative hypothesis would be mu is greater than k, strictly greater than k. And if the null hypothesis, if the null hypothesis is the population mean is greater than or equals to k, then the alternative hypothesis will be the population mean is strictly less than k. Okay, and the last case of hypothesis statement pairs is in the null hypothesis, the population mean equals to k, right, is k, then the alternative is the population mean is not equals to k. So there's only three possible hypothesis statement pairs that you can come up with using hypothesis testing. And another thing that you want to keep in mind is the claim, right? Those things that you claim or people claim can be represented as the null or as the alternative hypothesis. So it doesn't matter which hypothesis statements that you are claiming. So your claim can be either as a null hypothesis or the alternative hypothesis. But later we will learn that usually you do not try to support your claim if your claim is in the null hypothesis. We will discuss about those examples later. But at this point, you know that in hypothesis testing, you have two statements. One is a null hypothesis, another one is the alternative hypothesis. So in the null hypothesis, you always have statements of equality, right? You always have an equal sign. It could be less than or equals, greater than or equals, or equal. In some cases, people just use equals in the null hypothesis. But it's not wrong to use less than or equal, so then you would figure right away what is the alternative hypothesis, which is going to be strictly greater than, or strictly less than, or different than. Okay. And again, keep in mind that regardless of which of the three hypotheses that you're using, you always assume that the population mean equals to K. Right? You assume that the population means is the claim value, and then you examine the sample distributions on the basis of this assumption. Okay. So an example, your sampling, if your sample size is at least 30, then your sampling distributions is a normal distributions, right? And then you assume that your population mean, right, is equals to K. Right, that's what you assume. That's what your assumptions when you conduct hypothesis testing, and then you use your collected sample in order to test your claim. And then within the sample distribution, the sampling distribution here, you will determine whether or not a sample statistic, right, is unusual or not, right? If a sample statistic is unusual, which is somewhere on the tails, right, on one of the tails, that means you do not agree with the assumption that the mean is around K. If your sample statistic that you're collecting is far away from the mean of the distributions. All right, so that's the idea. How about let's do some practice on come up with the hypothesis statements, right? Example number 1. For each of the claims, state the null hypothesis and the alternative hypothesis in words and symbols. So first one, a car dealership announces that the mean time for an oil change is less than 15 minutes. Okay. So I need to write out the null hypothesis and the alternative hypothesis. And the claim is the mean time of an oil change, population mean, is less than 15. I know that mu is less than 15 is in the alternative hypothesis because it does not contain the equality. So once I figure this, then I can figure the null hypothesis, which is the opposite of the alternative hypothesis. Okay. So in words, you can say that the mean, the alternative, the null hypothesis is the mean time for an oil change is at least 15 minutes. And the alternative hypothesis is the mean time for an oil change is less than 15 minutes. All right, go to the second part of the first example. A company advertises that the mean life of its furnaces is more than 118 years. So again, we need to come up with the null hypothesis and the alternative hypothesis. More than, so we know that it has to be in the alternative hypothesis, right? So this is the claim, and the null hypothesis will be just the opposite of the alternative hypothesis. And then in words, you can say that the null hypothesis is the mean life of its furnaces is at most 118 years. And the alternative hypothesis is the mean life of its furnaces is more than 118 years. Okay. Next one, an automotive manufacturer claims that the mean for the gas mileage of one of the vehicles it manufactures is 45 miles per gallon. So then again, you need to come up with the null and the alternative hypothesis is, which is an equals, right? So that you know that this has the mean of the population equals to 45, which is the claim. And the alternative statement is going to be the mean is not 45. In words, you can say that the null hypothesis is the mean life for the gas mileage of one of the vehicles its manufacturers is 45 miles per gallon. And the null hypothesis statement is the mean life for the gas mileage of one of the vehicles its manufacturers is not 45 miles per gallon. All right, once we come up with the hypothesis statements, then we can talk about errors that we can make when we are doing hypothesis testing and the level of significance that we want to assign before using hypothesis testing. Okay. First, types of error. So the type 1 error occurs if the null hypothesis is rejected when it is true, right? So for example, you come up with a null hypothesis. Let's say this is look at this null hypothesis here, and is a claim. In this example, right, the mean for the gas mileage is about 45 miles per gallon. It's a null hypothesis, also is a claim. And then after you conduct a hypothesis testing, get the result from your sample, and you reject this claim. As a result, you reject this null hypothesis, this claim. But in fact, this claim is correct. This claim is true. So you reject the true null hypothesis. That is when you conduct type 1 error. You reject the true null hypothesis is type 1 error. And type 2 error occurs if the null hypothesis is not rejected when it's false. So the type 2 error occurs when you did not reject the null hypothesis when in fact it is not a correct hypothesis, right? What is in fact it is false and you did not reject it. So there's only two types of errors that you can make when you use hypothesis testing. And if you look at the table here, you can see that. So you have null hypothesis, right? One case is the null hypothesis is true. Another case is the null hypothesis is false. In your decision, you do not reject the null hypothesis or you reject the null hypothesis. So when you reject the null hypothesis when it's true, it is type 1 error. And when you do not reject the null hypothesis when it's false, it is a type 2 error. Let's look at an example on type 1 and type 2 errors in hypothesis testing. So someone claims climate change is harming the earth and that humans are causing it. There are four scenarios for responding to this claim. First, if the claim is true and I agree. Second, the claim is false, I agree. Third, the claim is true and I do not agree. And fourth, the claim is false and I do not agree. So look at this. Other possible scenarios. Which scenario is the result of type 1 error? Which scenarios is the result of type 2 error? And which errors are more dangerous? So look at the four scenarios. If the claim is true and I agree, so that is not an error, right? If the claim is false and I agree, that is not an error. So there's only two possible scenarios for error are scenario 2 and scenario number 3. So when you come up with the hypothesis type, this type of claim, the null hypothesis is always stating that there's no associations, right? Or the association is zero. So the association that we are looking at here is humans and climate change. Do humans cause climate change? And usually the null hypothesis should be no, humans are not causing climate change. And the alternative statement is yes, humans are causing climate change. And in this case, the alternative hypothesis statements is a claim. So as a reminder, type 1 error is when you reject the true null hypothesis, and type 2 error is when you do not reject, right? You accept the false null hypothesis. So type 1 error, true null hypothesis, that means the null hypothesis is true. That means the claims is false. False claims, right? And false claims, and I reject the null hypothesis, that means I support the alternative hypothesis. That means I agree. I reject the null hypothesis. I reject this false claim. That means I agree with this false claim. Right. I reject the null. I agree with the claim. So I agree with the false claim. False claim. So look at my scenario number 2 matches this definitions. Okay, the claims is false and I agree. That means humans are not actually causing climate change, and I agree with that. Okay, well, to go to the second type, type 2 error is when you do not reject the false null hypothesis. So the null hypothesis is humans are not causing climate change and is false. That means the claim is true claim, right? And I do not reject the no. That means I kind of accept the no. So that means I reject the alternative. That means I do not disagree with this true claim. Okay, so the claim is true and I do not agree. So my type 2 error is the third scenario here. So which error is more dangerous? What do you think? So, well, the type 1 means the claim is false. That means humans are not causing climate change, and I agree with that. Well, if I agree that humans are not causing climate change, I will just, I would not doing any work that reduce climate change or help with the climate change, right? I was just doing what I'm doing right now. So that's one thing. And then type 2 error is the claim is true. So the claim is true, which means humans are causing climate change, and I disagree with that. So I will disagree with humans are causing climate change. So that means I think that humans are not causing climate change. But in fact, humans are causing climate change. So I'm not, that means I'm not trying to protect the environment, right? I'm not trying to act on climate change activities in order to reduce the harms of climate change. So I think type 2 would have done more harms compared to type 1, right? Type 2 is then humans actually causing climate change. I'm not doing anything about it. And type 1, the type 1 error in this scenarios is human are not causing climate change. And I agree with it, right? I agree with the claim, but I still think that human are causing the climate change, and I start doing like things that I think that is good for the earth, when in fact that we're not causing climate change. So anyway, this is an example of how you would come up with hypothesis testing, and how can you distinguish between type 1 and type 2 error, which error is more harmful compared to the other one. All right. Of making type 1 error. The level of significance is the maximum probabilities that allow you to make type 1 error. And again, type 1 error is when you reject the null hypothesis when it is true, right? You're trying to do things, you make some errors when you run your hypothesis, but that alpha, the level of significance, is the maximum probabilities that allow you to make type 1 error. And the probabilities that allow you to make type 2 error is denoted by beta. And then in hypothesis testing, you have to come up with a statistical test. And from your statistical test, you can get the p-values, right, for your for your hypothesis testing. So a test statistic, right, is a sample statistic that is used in hypothesis test. For example, if you want to do a hypothesis test in order to respond to a claim about a population mean, then you want to use sample mean to test the population mean. If you are conducting a hypothesis test in order to respond to a claim about populations, right? Proportions. This is population proportions. Proportions. Then you can use the sample proportions to test the population proportion. Okay. And then you have two different standardized test statistics. You can use a z-test if sigma is known, and you can use a t-test when sigma is unknown. All right, and p-value of your hypothesis testing is the probability that you obtain from a sample statistic with a value as extreme or more extreme than one determined from the sample data. What does that mean? That means when you go out and you collect your samples, right? You assume that the population mean is K, right? When you collect your sample and your sample mean is right here, right? And you can find the probabilities that is greater than this sample mean that you collected for your sample. And this probabilities here is the p-value, depending on the type of the tests that you're gonna use. So the p-value is the probabilities that you're gonna observe an extreme or more extreme value than the one that you collected from your sample. Okay. And again, p-value is the probabilities that corresponding to either the right, the left, or on both sides of your sample statistic. So when the p-value of the sample statistics is relatively small compared to the level of significance, then this is a good evidence, strong evidence against the null hypothesis. And the null hypothesis is the population's parameters is the null hypothesis is the population mean equals the claim value. And that is when you can reject the null hypothesis. So again, if the p-value is relatively small, right, smaller than the level of significance, then you have enough evidence to reject the null hypothesis. And there's three types of hypothesis test. The first type is the left tail test, and you can determine the types of a test based on the alternative hypothesis, right? If it's less than, then it is the left tail test. And if it's greater than, then it's going to be right tail test. If it's not equals to, that means it's a two tail test. Okay, so in the left tail test, the p-value is going to be the area to the left of the standardized test statistic. And in the right tail test, the p-value will be the probability to the right of the standardized test statistic. It can be z or t, right? And the two tail test is going to be the area, like p-value will have, is going to be 2 times of the area on the two tails of, right? If you come up with, this is the test statistic z or t, and you can find the probabilities to the left of this test statistic, and then you multiply this p-value by 2. If you have a right tail test, then this probabilities here is just going to be your p-value. And again, you have z or t as a test statistic. And you have z or t is a test statistic. If you have a left tail test, then this area here will be your p-value. And once you come up with your p-value for your test, you can compare the p-value with alpha, which is the level of significance in order to make decisions, whether you reject the null or fail to reject the null. So if p-values is less than or equals to alpha, then you reject the null, right? Because it's small. If p-value is greater than alpha, then you fail to reject the null. That means you kind of accepting the null. So there's a say that helps me to memorize this rule, which is if the null is too low, then if p is too low and the null has to go. Let's say if p is too low, then the null has to go. So that means if p is less than alpha, right, then you reject the null hypothesis. And how can you interpret your decisions? There's two different possibilities for where the claim is going to be, right? The claim can be in the null hypothesis, or the claims can be in the alternative hypothesis. The two possible decisions that you're going to do, which is either you're going to reject the null hypothesis or you fail to reject the null hypothesis. So if the claim is in the null hypothesis and you reject the null hypothesis, that means you have enough evidence to reject the claim. If the claim is in the null hypothesis and if the claim is in the alternative hypothesis and you reject the null hypothesis, that means you have enough evidence to support the claim, right? Because you check the null, that means you supporting the alternative. And if the claim is the null hypothesis and you fail to reject it, that means you do not have enough evidence to reject the claim, right? You cannot reject, you fail to reject it. And the last case is if your claim is the alternative hypothesis and you fail to reject the null, that means you're supporting the claim, right? So then you can say that there's not enough evidence to, you fail to reject the null hypothesis. That means you kind of accepting the null hypothesis. That means you do not support the alternative. If you do not support the alternative when the claim is in the alternative, that means you do not have enough evidence to support the claim. So this table here helps you to interpret the decision that you're making. Again, is depending on where the claims is in. The claims is in the null hypothesis or the claim is in the alternative hypothesis, right? All right, let's look at an example. Let's say a consumer analyst reports that the mean life of a certain type of automobile battery is not 74 months. So the mean life is not 74 months. And first state the null and hypothesis testing. So the null is not, it has to be in the alternative and different than, and then this equals to. Okay, so that's a null and hypothesis, an alternative hypothesis statements. The question is, how should you interpret your decision if you reject the null hypothesis? And we know that this is the claim, right? So if you reject the null hypothesis, and that means you support the alternative, and the alternative is a claim, that means you support the claim. You can say that there is enough evidence to support the claim that the mean life of certain type of automobile battery is not 74 months. So that's the claim. Okay, so this is 1, this is 2. Now, the third scenario, how should you interpret your decision if you fail to reject the null hypothesis? So fail to reject the null, that means you do not support the claim, the alternative, which is the claim in this scenario, that means you do not support the claim. So then you can say there is not enough evidence to support the claim that the mean life of certain battery is not 74. So that means some of the batteries has a mean life that is either less than 74 or greater than 74. So this is how you, depending on the scenario, depending on your claim, you come up with a null and alternative hypothesis. And then depending on your the sample that you're collecting, depending on your test result, you can make a decision whether you rejecting or fail to reject the null hypothesis. And from these decisions, you can try to come up with the right way to state your decisions, right? Whether you have enough evidence to support the claim or not. So there are some strategies for hypothesis testing. For an example, in a courtroom, right, the strategy used by an attorney depends on whether that attorney is acting as a prosecutor or as a defender. Similarly, a researcher would state the hypothesis statements depending on whether they wanted to support or reject a claim. And then one thing that you want to keep in mind, remember that you cannot use a hypothesis test to support a claim when your claim is the null hypothesis. It's just like you're not going to go to the court and claiming that you are innocent and trying to prove that you are innocent. Nobody accusing you of anything, you're just trying to prove that you are innocent. That doesn't make sense. So the same thought will apply to hypothesis testing. Right? You don't want to support a claim when the claim is the null hypothesis. So let's look at example number 7. You represent a chemical company that is being sued for paint damage to automobiles. You want to support the claim that the mean repair cost per automobile is less than $650. Then the null hypothesis and alternative hypothesis. So the mean cost is less than 650, right? And then in the null hypothesis has to be at least 650. This is your claim. And if you want to support this, is fine because the claim is in the null hypothesis. Because the claim is the alternative hypothesis. Okay? And then you can support it. How would you interpret a decision that rejects the null hypothesis? So if you reject the null hypothesis, that means you support the claim, the alternative, and the alternative is the claim. So you supporting the claim. All right, and the claim is the mean cost is less than $650. Example number 8, you're on a research team that is investigating the mean temperature of adult humans. A commonly accepted claim is that the mean temperature is about 98.6. You want to show that this claim is false. Write your null and alternative hypothesis. The null should be mean equals to 98.6 and the alternative should be different than 98.6. Okay. And this is the claim. And in this case, you do not support this claim. So this claim is a null hypothesis and you do not support it. That means you can use a hypothesis test to test this claim. If you reject the null, that means you support the alternative, right? And the null is a claim. So that means you have enough evidence to not supporting the claim. Or when you reject the null hypothesis, that means you're rejecting the claim. Or you don't have to look at the alternative at this point, right? Because the claim is in the null hypothesis, you're rejecting it, that means you reject or do not support the claim. Well, that means you, if you found enough evidence to reject the nulls, you can say that the mean temperatures of adult humans is not, you don't have enough evidence to support the claim that the mean temperatures of adult human is about 98.6. It can be less, it can be more. You just don't have enough evidence to support that the mean temperature of adult humans is about 98.6. All right, again, this lecture introduces the idea of hypothesis testing. How can you come up with the hypothesis testing statements? How can you determine which pair of hypotheses that you're using depending on the claim? And How can you determine whether you're making type 1 error or type 2 error? Which type of error is more dangerous in different contexts? How can you use level of significance and the p-value of your hypothesis test in order to make decision whether you reject the null hypothesis or fail to reject the null hypothesis? And how can you interpret your decisions based on each context?